guys, welcome to this video where we're going to have a look at an introduction to the topic of integration. Okay, so this topic's something new, okay, but it is related to the work that we've been doing on differentiation. If you like, it's an extension of it, and let's just get straight into it. Now I just want to remind you of some of the material which is going up onto the OneNote that you should be accessing at times. Okay, so here is some material I've put up about integration, a few notes here which is pretty similar to what's in your workbook on page 169, but this is another place where you can find that and a brief explanation of the idea of integration. A copy of the achievement standard here, and when you scroll down, the rest of the achievement standard is there. Also, I've was looking at some material on integration and came across a pretty useful website here called Math Tutor, and it's got quite a bit of useful material about integration here, so that is something that I would recommend you have a look at as well, especially if you want to hear a different explanation, perhaps a better one than the one I'm giving. Alright, so let's get into integration. Well, for a start, what we're going to do is have a look at the idea of integration essentially as the opposite process to differentiation. Now, we've had quite a bit of a look at how to differentiate different functions, and we're going to start off with looking at polynomials, just like we did with differentiation, and we'll see that the process of integration is the opposite to the differentiation process. And as I've mentioned up here in this note, that different integration is essentially an algebraic process at this stage known as anti-differentiation. We'll see that there is more to it later, and that there are applications of integration to things like area that it's going to be an extension of the simply algebraic process that we're having a look at the moment. Okay, so for a start though, let's just consider what integration is and as a process which undoes the process of differentiation. Alright, so I'm just going to swap to being able to write on the screen, so let me just do that. I'll use Blackboard here, and let's get a better color that we can see. Okay, so integration, and at the beginning of this topic we'll consider this as a process of undoing differentiation, or otherwise known as anti-differentiation. Okay, so let's start off with a pretty simple function. Let's take a polynomial. Okay, let's make it a quadratic. Yeah, we'll put a constant in there. And let's consider what the derivative would be. Okay, so if we just apply the process of differentiation, okay, using the power rule, okay, that's going to be 2 times 3 x, and take 1 off that power, so we get 6x. And if we do that to the other terms, we end up with 6x plus 5. Notice that this constant here has disappeared when we've differentiated. Okay, so this was the process of differentiation. Now, what I want to consider is there a process that we could do that would take us from this function back to this one? And that is known as anti-differentiation, or more accurately, integration. Okay, so how would we do that? Well, let's consider that 6x term for a moment. Now, if I wanted to go from 6x back to 3x squared, now remember what we did in the process of differentiation. If we had some sort of polynomial term, or this could also be in other power functions as well besides polynomials, but when we differentiated with respect to x, what we did was we multiplied a and n together and then took 1 off that power. So it was a times n, x to the power of n minus 1. Now if I want to go from this thing here, back to this here, what would I do? Well, let's consider this example. If I want to go from 3x squared, from 6x to 3x squared, what I'm going to need to do is, I think we need one more power than what we've currently got here. So I'm going to add 1 to that power, and then if I want to get that 3 in front, I'm going to divide by this new power here. So if I do that, then we're going to end up with 3x squared. So if I generalize that, okay, if I were to take this here, and if I add 1 to that power, okay, that becomes just n again, and if I then divide by that new power, which is n, then it's going to take me back to ax to the power of n. Okay, let's just tidy this up, just try and make that a little clearer. Okay, that and that will cancel, and we'll end up with a times n x to the power of n, and if I divide by the new power here, which is n, okay, yes, it does take me back to ax to the power of n. They cancel. Alright, let's maybe have a look at that with the 5x term. So if I derive that, I got 5. So if I want to go from 5 back to 5x, well, this is 5x to the power of 0, don't forget, and this is 5x to the power of 1. So if I take this thing here and I take that power and add 1 to it, 0 plus 1 being 1, and divide by that new power, it takes me back to 5x. So once again, it looks like what I'm doing is I'm adding 1 to the power and dividing by the new power. Okay, so what about the 3 term here? Well, then we run into a problem, because at the moment when we look at the derivative, and if that's what we're starting with, I don't know if there was no constant here, or if there in fact was some sort of constant here, but I don't know what that constant might have been. Because consider, if I change that constant to say something else, so instead of plus 3, it might have been plus 17. But when you derive 17, it still gives 0. So there's no way, if you start with the derivative, of knowing what this constant at the end might have been. It could be 3, it could be 17, it could be negative a million, it could in fact have been just 0. Okay, so if you derive that, you still get the 6x plus 5. So how do we deal with that? Well, what we're going to do is we're going to put in our answer a constant that might have been here. Right, so let's tidy this up. Let's just go to a new page and say, right, if I want to integrate or anti-differentiate, not the 3x squared, but the 6x plus 5, okay, we need to somehow tell the reader that we're going to integrate. So here's a new symbol. Okay, it looks like an elongated sort of stretched S. like a snake symbol. Okay, and what we're going to do, usually put that in brackets, not always, but usually, and we're going to say what we're going to anti-differentiate with respect to the x variable. Okay, so if we follow through that process again, how did we do that? Okay, we added 1 to the power here and divide the constant in front by that new power. Okay, and if we had 5x to the power of 0, if we add 1 to that power and divide by the new power. Okay, and what about that constant that was there? Well, I don't know what that was, so what we do is we put plus c to stand for the constant that might have been in the original function, even if that was 0. So our final answer will look like this. And remember, the original function that we started with was this, so we're pretty close to it. The only thing missing is this 3 here. So how could we get back the actual 3? Well, we'll need more information. And for now, we're simply going to represent that constant that might have been here, like the 3, with the plus c. Okay, so just to generalize again, okay, and I'm just taking what's in your workbook here. Each term that we're integrating, or in other words, anti-differentiating, what we're going to do is we're going to take the x term, add 1 to that power, take any constant in front, even if it's a 1, and divide by that new power. And we'll also have a plus c at the end of our working. Okay, let's take a look at one more example. Now they work through a pretty comprehensive example on page 169 of your workbook. Do have a look at that one because it's a good example. I'm going to try and take something which is also reasonably challenging here. So I'm going to have a look at question 9 on page 170. Okay, and this was where we've got the integral of the square root of x plus 1 over x squared. Okay, now what we're going to do is we're going to need to put each of these terms here into this kind of power form. Now don't forget a few basic maths things, that the square root of x as a power of x would be x to the power of a half. 1 over x squared as just the power of x would be x to the power of negative 2. So I'm going to rewrite the terms like that. So don't forget your integration symbol. Don't drop that off as you go. And then we're going to apply this anti-differentiation rule to each part here. Right, so let's start off with x to the power of a half. Now half plus 1 is 1.5. Okay, that's fair enough. But 1.5, I'm going to write that as a top-heavy fraction, and I'll explain why in a moment. Okay, and now what we're going to do is we're going to take the coefficient in front. Now what's the coefficient in front? Well, at the moment it's an invisible 1. So we're going to divide 1 by 3 over 2. But 1 over, or divided by 3 over 2, well, that's the reciprocal. So it's going to be 2/3. So in a moment I'm going to rewrite that number in front as 2/3. Okay, let's carry on. Do this next part. X to the power of negative 2. Now negative 2 plus 1, often I get students write negative 3 there, but of course it should be negative 1. So x to the power of negative 1, and we've got a 1 in front, and we're dividing that 1 by the new power, negative 1, and plus c as y plus c because of the reasons I explained previously. Okay, tidying this up, 2/3 x to the power of 3 over 2. 1 divided by -1 is -1, plus negative, that's the same as minus. So minus x to the power of -1 plus c. Now I suspect that if you look in the back of the book, the answer will be written in a tidier form than this. Okay, so x to the power of 3 over 2, well, that is the square root of x cubed. The square root means second root, so that's how you put it back into root form. So this part here could be written as 2/3 times the square root of x cubed. That's a cubed. And what about x to the power of -1? Well, if you rewrite that as a positive power, it'd be 1 over x. So minus 1 over x plus c. And maybe this might even be written as 2 square root of x cubed over 3. Now, which answer would be acceptable in the NCA exam? This one here, or this here, or this here. Any of those three would be fine. Okay, so that was another example, and what we're going to do in class is to try and work through quite a few more of those. If you do have any questions, please email, and I will also pop in a couple of questions that I'd like you to have a go at just to see if you are understanding some of this material now.